Okay, welcome back. Literally, just as I clicked stop on that last recording, I got a message on Teams from one of your advisors who wanted to come to lecture and talk about the FAS mentorship program. And I said, well, it's kind of the end of the semester and kind of not a lot of lectures left, but hey, I could be a team player. There's something called the FAS mentorship program. Um, it's like you all are the ones being mentored in this story. It's career mentorship, and yeah, aims to provide undergraduate students. Stephanie suggested like over 60 credits kind of range. In the later half of your undergraduate career, clarity on how to transition to the workforce seamlessly. That sounds awesome. That seems like something you might want. So I will also point out, because I do get questions about this, right? Because this course feels kind of practical, and people are like, oh, I want a data science job, something. Look, I support your desires. I haven't applied for a job in 25 years. What do you want from me? You want some boomer advice? It's like, print out your resume and give the man a firm handshake. I don't know. Um, if this, like, I wonder sometimes why we have to promote this sort of thing. There's somebody who wants to help you. These are well-meaning people, professionals in the field from the tech, like, why the hell not? Why do they have to ask students for this? Y'all should be banging down their door saying like, oh my God, I heard about this mentorship program. Anyway, what was I talking about? Data frames. Right. So we have the two data frames tools we've had up to now, Pandas and Spark, and then polars, which I think, I think my summary of polars would be, okay, like it's different, sure, than Spark and Pandas, but pretty sane. Like in ways that, like, Pandas is sometimes nuts in its syntax or the way you have to express some thought. The fact that square brackets are used for like 6 different things. Polars is, yeah, I want to select this isn't, yeah, that's very similar to the thought that I have in my head. I want to group by this and aggregate by that, great, or aggregate with that, cool. And I can choose strict evaluation, or I can say, like, if I have a data frame, I forget the method called, .stream or .lazy or lazify. There's some method that will turn it into a lazy frame. Then you can do like 7 steps of a calculation lazy, and then just say .collect and get a data frame back. And I can choose that like line by line if I want, and that's really cool. And huge speed difference, huge memory footprint difference, because again, if you're doing lazy evaluation, you're not keeping all the things in memory. If you're doing strict evaluation, you pay a little bit for that, but these are massively different times for very similar thoughts. And I think this is my summary. Like, again, the way you express your thoughts in polars, it just shows the timing of it. Like, they have had decade or whatever it is of pandas experience, of people using pandas and being annoyed with pandas and trying to figure out, how do I do this? Why is this so hard? And Spark has been in the middle, and all these other data frames tools. So they just have the benefit of experience and what kinds of things do people want to do and what's a good way to express it. It's fast. Again, Rust programmers tend to, no guarantees, but they tend to care about every CPU cycle and every byte of memory. The polars people obviously do. They are very interested in using your processor to its fullest. That's great. Again, I paid for it and I don't want to do that. I don't, if I can avoid it, I would rather not worry about these things. I just get them for free. That sounds great. It's not a big data tool. It's not, it doesn't cluster. Sort of. So with the lazy frames, I'm not memory restricted, and that's great. Once again, this number on a many times bigger data set didn't change very much. It did get bigger, like more so than Spark did, but I can work on a data set that's much bigger than my memory because it's not going to calculate it and try to bring it all into memory. There's a bunch of ways to express yourself in terms of like, how do I want to deal with? So like what I did was I turned a lazy frame into a data frame and then just wrote it. There's also this other way to like to stream a lazy frame onto disk, or this way to do that. They all were within a tenth of a second of each other on this code for me today, this Polars version. But yeah, who knows? They're trying to be helpful, right? Like it seems like these things are being added well. This seems to be the place where they're not open source about it, but I guess if they draw the line cleanly, that's okay. So they have a like .remote, which is send your calculation into our cloud provided or our cloud offering, and then do it as a distributed calculation. Okay, so one thing I guess that's happening here is, before this code snippet, everything is exactly as it was before. Like all the code that I could have written before, I create a lazy evaluated execution plan or whatever they call it, and then I just say, oh, actually I want it done over there, not here. That's cool, at least. Like it's a good way to express that thought. And I do get some kind of big data-ish thing. I have not tried it. They also, like, you can express, again, with a lazy frame, you can say, this is maybe not the page I want, but anyway, you can express, instead of doing that computation on the CPU, I would like you to do it on my, CUDA compatible GPU, please. That's great. Like, it'd be great to say that with a single option if that's useful to me. I don't think it is in this problem, but, and I think I stand by my summary here. I don't think Polars is the only data frame tool I need in my life, but wouldn't it be awesome if it was? If they demonstrated to me that they could do distributed computation the way, with the same scalability that Spark can, and that they're compatible, like people use them and you can get help in the same way you can with pandas, I would love to just say, the only thing I'm teaching and the only thing I'm using is Polars, but that's not the current reality, sadly. But it's a great tool. Maybe worth keeping in mind. Again, if you have a moderate data set for your project, maybe you can switch some of the code to Polars and see what happens and put Polars on your resume. Why not? Okay, since I'm comparing data frame tools, let's talk about something that's definitely not a data frame tool. If you know what SQLite is, SQLite is a transactional database that's like just in memory, like it's part of your process. You don't have to start a server and whatever. DuckDB is the same like category of product, but optimized for analytic queries, data science things. So it's basically, you get to think about SQL and SQL operations, but you get really fast analytic queries. Well, that sounds like something I might want. Again, if you are comfortable expressing yourself with SQL queries, then great. Installing a database server is annoying, and I mostly don't want to. If I'm going to do analytic things, maybe this is a tool. If I'm going to do transactional things, maybe I should think about SQLite. But let's try it. Okay. Again, like it says connect here. There's nothing I'm connecting to. I'm just like starting a DuckDB existence. And then I don't know if this is the best way to do this, but this is select star from read CSV, like inputs / with, again, the same kind of thoughts I had to express to Polars and to pandas, which is there's no header row in this CSV. And also here's my column names and their types. Why did I bring them all in as characters? Oh, no. Okay. This one's an integer. Everything else is characters. Sure. Okay. And then I can just, so I created this thing called weather. I can now refer to it as weather. And I can do the stuff I talked about before, as, again, like expressed as a SQL query now. So on my DuckDB thing, out of this table, I guess, is probably the noun. I want this, and I want that, and I want that, and I want to filter this way. Okay, that's like the entire first couple steps. And then I'm going to group by date, and aggregate this way. Slid a data conversion in there because I want to write files that look exactly like my other files, and then output. Again, I don't know if this is the best way to do this, but I did it and it worked. So basically, if you think this is more beautiful than the like pandas or polars or what you wrote in exercise 9, maybe DuckDB is your friend. It's really fast. It's time competitive with polars on this task, and also memory footprint as well. Again, they care about every CPU cycle and every byte of memory as much as they can. And so they publish these benchmarks. I don't know if the visualization is pretty dense. Maybe the table is better. So they did this in whatever this is on 128 cores. They're multi-threaded, so many cores is good. On a 50 gigabyte data set in 20 seconds, 21 seconds. Polars are 75 seconds on whatever task we're talking about here. Pandas, it got there. Again, much slower, but it did get there. For some reason, they didn't do it in Spark. And as you look through, there's a bunch of other tests here. I don't know why we're not. Yeah, like I don't know why we haven't done these tests in Spark. This one got done in Spark and it was slower, but it's on a smaller, Spark is good at big data and lots of CPU cores. I don't know why they didn't run it there. Anyway, any project that publishes this, right? This is official DuckDB content. If they're publishing these benchmarks, they care about them, right? They are looking for every bit of performance they can get and give to you. That's great. This is a noble goal for them. And I think DuckDB and Polars are competitors in the sense that they're in that same space of I'm going to do my compute on one computer. I don't need a compute cluster, but I do want to use all my CPU cores. I want it to go as fast as possible. Those are really great tools for that. I don't want to keep all my data in memory, also important. These seem like really good computers, or really good compute tools, sorry. Maybe I should keep those in mind. Here's another one. Dask is wild in that they are very much saying, we want to be compatible with your existing code. You got some pandas code? Great. We'll make it go faster. In fact, we will make it run on a compute cluster in the same way that the Spark Pandas API does, but we'll do the same thing with your NumPy code and your scikit-learn code. And this is crazy. Probably shouldn't work, but it does. So again, you've got a Dask data frame instead of a Pandas data frame. Otherwise, I did have to give, again, I had to read the file different. This was the same in the Spark Pandas API. You have to sort of start different. You have to create the thing in a different way, in a different framework with a different library. But then this code is exactly the code I had a dozen slides ago for pandas. So if I had made you do exercise 9 with pandas, which you could have done, you'd have got there. This code is exactly what you would have written. I did have to make a little one argument change here, but very, very little. And then I just say .compute, because it turns out this is all lazy evaluated, even though it's the same code as pandas. So again, I have to finish in a different way. I say .compute to actually get the thing done. And then I have I don't know what I have. I have a materialized Dask data frame, probably. Maybe I have a pandas data frame, although I doubt it. Probably I have a Dask data frame that happens to exist in memory. Then I can write it to disk. Again, exact same output for all of these. Much lower memory footprint than pandas, because it's lazy evaluated. It's streaming all this stuff. It's not keeping the intermediate stuff in memory. It's taking its time. It's certainly not as slow as pandas, but is slower than the other tools we've seen. So I'm not sure here. maybe what's happening is if I could scale this up by another 10 or 20 times, Dask would start to show off a little bit more. Because again, they do distribute. You can run them on a compute cluster. Maybe just Dask is, because it's another typo there. No, I don't. There was never a typo. I was at war with East Asia. So maybe. I would argue, like, maybe the cool thing about Dask is its flexibility. That, okay, you can have a data frame. That's a data structure you can have. Also, you can have a bag, which is, again, I think analogous to a Spark RDD. It's, you know, roughly a distributed list, but you're not going to worry too much about the order of it. Or there's these like more build a workflow kind of operations that I want to take this and the output of this goes into here and the output of that goes into there, and okay, now do it all, get it all done somehow. Also very cool. Or somewhere in here, there's a bunch of like scikit-learn compatible function calls where you can take your, you know, they hope they are doing their best to turn your NumPy or scikit-learn or whatever into distributed implementations, which again, awesome. You know, like I support their goal. There's a bunch of like the ways you can deploy it are crazy. Like you can just run it, you know, like I just did. You can, once again, you can use their cloud offering to run your code. Coiled is the company that either created or spawned from Dask. I'm not sure which way that causality went. Or you can run it on the like job, well, sorry, whatever job queue is, or on an MPI, like any of the supercomputer contexts. Or like you can have this kind of crazy ad hoc cluster thing, like just set up a bunch of computers and tell them they're workers now. That's really cool. Like it's really an amazingly flexible tool. Yeah, I think so. I mean, there's the Spark Pandas API that is a way to get existing Pandas code to go faster and scale up. This is another way. It's not at all clear to me which one is better, or that there is one that is strictly speaking better. Much like the Spark Pandas API, the weird stuff that happens in a distributed system isn't expressible with the Pandas API. They don't need methods for that. Maybe you don't care. Like maybe like whatever problem you're imagining that has scaled past the place that Pandas can naturally work, maybe you don't care. This isn't relevant and you don't need to worry about it, but sometimes you need to worry about it, and having it completely inaccessible would worry me. So I don't understand why, like are they not advertising the like machine learning and stuff, or maybe they've spun it into a different project maybe. Yeah, anyway, it's there. Again, do you need it? Well, I don't know you. Who knows what needs you have. Like this, again, I've run Dask jobs, and you get this like great visualization of like how were we using all your CPU cores millisecond by millisecond, and what was taking the time, and it's really cool. Like, it's a great tool. It's just whenever I use it, it seems slower than its competitors. I used the phrase GPU when I was talking about polars, and it turns out there's another like Pandas, or like Pandas code but make it go fast. This one from NVIDIA, which is cuDF, that's how we pronounce that? Sure. That is, take your data frame and send it into your VRAM and have it manipulated by CUDA things on your GPU, and which is a much faster processing tool than your processor, if the things you are about to do can be done on a GPU, I don't know what you're about to do. I'm not even going to try this one. There's no way that the amount of compute that I'm doing in this example makes sense for this. So I'm not going to pretend. But here's where we got. Again, pandas this is the default, right? For all your data needs in Python. Realistically, like, this is probably your first choice. And then I have, like in this semester, we presented this like, oh, but there's this other thing for big data where the data can be really, really big and it's okay. Maybe because it doesn't store in memory, maybe because it uses all your CPU cores, maybe because it uses all the CPU cores on some massive compute cluster. But what we've got today here is these other competitors that, like, this is blazing fast. And okay, I would have to rewrite my pandas code to take advantage of it. But if my thing fits in memory, or it doesn't have to fit in memory, if my thing can be done on one computer within reason, well, maybe I don't need Spark, and this starts to look pretty attractive. Or DuckDB in that same category. Obviously, this is not definitive, right? Like, this is one task that I made up because you kind of understood it and whatever. Those Dask benchmarks are much more complete, or like they're much broader. They test a whole bunch of different operations. I think some of what's happening here, like you can just see when you run Spark, you can just sort of see that time it takes to start up before it even looks at your code. And the same thing happens in Dask, at least for some of that time. Because they're complex tools, they have to sort of orient themselves to like, hey, what's a context here? Am I on a compute cluster? Am I on one computer? Am I on a supercomputer? Like, what's happening? So some of that they have they're kind of restricted by that, right? They're always going to have that complexity, but that you hope will pay off in the tasks they're good at. I think Polars and DuckDB deserve attention because I know that a lot of data I work on is not at that scale, where Spark is really necessary. And if I can just use all the CPU cores and efficiently use the memory on my computer, it'll be fine. And they're happy to help me with that. This slide deck has been hard. Like just keeping track of like, what are the data frame tools? How far back do I have to go here? There we go. This is the DuckDB benchmarks. Like, okay, they have data fusion, ClickHouse I'll talk about in a bit. I genuinely don't know what CHDB is. Dataframe.jl, probably in Julia, probably hasn't come across my, like, there's all of these things, and these are also Python data frame tools. And I think, like some of them I tried and I couldn't get this task implemented, so I didn't include them. Some of them seem like nobody really uses them. It's so hard to keep track of this. And the category is very often like pandas but faster. Like, this is often the pitch. Dask is like pandas but faster, or even like pandas so much that you can just use your existing code. Polars is like pandas but faster, but you do have to rewrite your code. Yeah, that it's a competitive task, a competitive space. I don't know, like these, again, coil.io, which is this one and this one, those are DuckDB people. Like, they're going to be talking about DuckDB in favorable light, kind of inherently, but they're honest about it. Like, so yeah, I don't know. I think it's worth keeping these in mind. If you end up in a data world in your, in the next few years, keep in mind, these tools are out there. Let's talk about some other tools that are out there. All of the data frame tools, we're doing this kind of thing, right? It's, well, read the files, like, let's be clear on what we're doing, but yeah, we're reading data from files and doing, programming-y stuff on it. There's other things you can do. Let's see here. What might actually matter to us? I mean, you can read Excel, which again, like maybe this is an ETL task. I've got this horrible Excel spreadsheet and I just need to get it into something useful. You can do that. Where's the things I want? Okay, Parquet, great. Like Parquet files are very useful. Apache's iceberg format, sure. This is one I want to point out. You can read a database table into a pandas data frame, or a Spark data frame, or a Polars data frame. They all have some version of this. So you need to connect to it somehow. And then you can say which columns you need, because of course, pandas is going to bring all this into memory. So you maybe don't want to do more than you want, but actually maybe what you want to do is just do a query. Like you can just do a SQL query here and just filter out the columns and rows you don't care about and bring only that like subset, then start working with it as pandas. That's pretty useful. But maybe this is wrong, right? If what you're doing is a problem, right? You have a thing to do with the weather data because you're doing exercise 9 or whatever, fine. Like read the file, hooray. Sometimes what you have is a complete like an analytics for the entire company kind of thing. And you got to do this analysis for the sales and this thing for HR and this thing for the management or whatever. And all of a sudden, gross. I have to read all these files all the time and parse them a whole bunch. Okay, maybe I'm looking at this all wrong. Maybe what I should do is I have a database. Come on, databases are databases. They're places for data. Why don't I just use that? And this is sort of what DuckDB is saying. Like, the way we speak to databases with SQL queries is pretty useful. And you probably, if you don't already know it, if you're going to be any kind of data, anything, you need to. Maybe, sure, right? So what are we doing? Why don't we just use the database? We have whatever I'm imagining here, right? I have to do this report for the marketing team. Well, there's probably a database, right? There's probably something like, the website runs and customers buy things, and then the things they bought are in the database. Why do I need any of these tools? The data's already in the database. Maybe I should just do all my analytics on the production database. And that's a thing. It's totally plausible, but here's why it's probably not what you want. And reason one is people are going to be mad. A database that's backing a website or something else, but I'm going to just imagine a website. What you expect for a database is like under 100 millisecond kind of latency. You expect to be able to say, because a user just clicked on a, my orders page. So you want to be able to select from all the orders where the customer is that customer, and you want to get that data and turn it into HTML and show it to them real fast. If that story happens when you're in the middle of writing some massive query that generates some report, and all of a sudden that takes a second instead of a tenth of a second, people are going to be cross, and quite rightly so. The second reason, and I guess like when talking about like SQLite versus DuckDB, I said this, it's just that's not what the tool is for. If you think about 354, or if you've written a website that had a database behind it or whatever, what you were doing were online transactional operations. Probably, I don't quite know what's happening in 354, but this kind of thing, right? It's, find all of the things that this person bought, or this person just added something to their cart. Add a row to the carts table that is this user, this item. That's transactional work, or it's what's called OLTP work. If we're thinking about data science, we're probably in more of an OLAP world, which is, instead of these simple like work on a couple of rows operations, I'm going to do all of the kind of operation. Exactly the kind of thing we've always been doing with data frames. I want all of the purchases from the last year organized by region because I have to present regional data to the marketing, whatever. That's now an analytic tool. Maybe it's not what your database is designed for. Like Postgres and friends can do this, probably. It could be that, again, doing it beside your OLTP work is going to slow that work down. Maybe it's that your database schema that makes total sense for transactional work doesn't make sense for your analytic work. Part of the problem with this is life isn't as simple as it sounds in the databases course. It's all well and good to say you can have a database server with multiple databases that are doing different things, or a single database with many, many, many tables, but that's just not how things work in any organization. At SFU, the fact that you are registered in this course and you have a grade of whatever, that's in GoSFU, the PeopleSoft system, and it's backed by whatever database. The fact that I work here and will get paid next Friday is in a different system because it's a different tool that does different stuff. And the fact that whoever, like I don't, but whoever else has this research grant, different system. All of these things are in different places. So if I want to ask questions about like how much people get paid versus how many students are in courses or whatever, there's no join that can do that because they're different, completely different databases unrelated to each other. Okay, so, new idea. Let's get all of our data into one place. If having it in multiple places is bad, or if the place that it lives right now is bad for analytics, have somewhere where all the data can be and it's good for analytics. That's a data warehouse. So the idea here is it's probably going to be a copy of data or a replica of the data or something like that. Maybe it's just a database. Like maybe we have a Postgres database that backs the website, and we have a read-only replica of that database that we can hammer with big analytic queries. And if those queries bog it down for 60 seconds, nobody's mad. Totally possible. Or there are just things that are data warehouses that are good at this. They're designed to be good at this. Part of the reason data warehouses get a lot of attention is there's lots of people who would love to sell you that. But Amazon Redshift is basically that. It's, hey, do you want to get all your data from wherever the heck it is into one system and then query it with SQL queries? We'd be happy to rent you that. It can be done, sure. If you're going to have a separate copy of your data, you have to make a separate copy of your data. That might be bad. Maybe I can make my life better as part of that. I can reshape the data into something that will work and that I can query in an analytic way. Maybe that sounds great. This is a very much an it depends thing, right? If I have a dozen data sources with really gross formats and I have an entire data team that is going to query them all day and write a whole bunch of reports, I probably need a data warehouse. If I have to do one query once a month that tells people how many whatevers, maybe I'm just going to do it I don't need a data warehouse. I'm just going to do it against the production data like at 2 in the morning or whatever. Also possible. I am going to look at ClickHouse. What's ClickHouse? Oh, God. Oh, great. It does the AI. It's not an AI tool, guys. It's really not. It's an OLAP database. It's a database that is like DuckDB, optimized for analytic queries. Unlike DuckDB, it's actually a server. Like it's a thing that you start up and you run and you connect to, and it stores your data. Well, this is what I just described here, right? It's somewhere to store a presumably copy of my data, get it all together, and query it doing OLAP things. That's exactly what I just described as ClickHouse. So maybe ClickHouse is a good data warehouse tool. And maybe it's a good AI tool, whatever the hell that means. So I'm going to do the same thing. The same, like get the weather in and then query it and find the hottest Canadian temperature on each day. I'm not sure I did this well. What I did was read the data with polars and then chunk it off into my ClickHouse data. So there's a better way to do this. I don't know. I did this and it worked. Take chunks of the thing, convert it to an Apache Arrow format, and then you can hand that, fine. That got my data in. So that's my create the data warehouse step. Took some time. Maybe there's a better way to do it. I don't know. But the idea is that now that my data is in my data warehouse, I can hammer away at it. I can do all of these super efficient analytic queries, and that'll make my life good. So what I've done here is all that stuff I talked about as one massive nested query. So this is, and I think I took this straight, more or less straight from the DuckDB code. Do the query that is like sort of the ETL of my data, and then do the query that is on that of, and I want to find the max temperature on each date. And I guess, and materialize it. So this is actually take that and store it in a new table called max date. I don't know, like I didn't have to do it this way, but I chose to. I could have just taken this and like queried it back into Python or something. I don't know, like if this, what is this dozen or so lines of SQL, like if this makes you happy, maybe things like DuckDB and ClickHouse are for you. What I did then was just, I took that, I brought it back into Python as a pandas data frame. Yeah, pandas data frame. Because then I could just do whatever. I wanted to write a file that so I could get the same result as that other code from back here on this other slide deck. That was really fast. Well, sorry, this was really fast. It still took 35 seconds or whatever it was to get the data into ClickHouse. But now it's half the time of any of these data frame tools from before. Now, totally an unfair comparison, right? Because this 0.7 seconds, it had to read the files out of CSVs, and this 0.3 seconds did not. But that's the whole point. If I get my data into a data warehouse, then I can do this query really fast. And I imagine I have another 100 queries to do because I'm a data science team, and that makes this totally worth it. If I'm in that scenario, I want that. Like the fact that this is an unfair comparison is totally the point of having a data warehouse. If I have a lot of queries to do, it totally makes sense to have this thing set up to store a separate copy of my data, to update it nightly or whatever, because I need to do data work. But maybe it doesn't too, right? Maybe I'm in some different scenario, which is I'm gonna leave my data. I don't want to move my data around. That's a waste of time. I'm just gonna leave it where it sits and I'm gonna query it. Now you wouldn't think you need a term for that, but that's what data lake means. Data lake is a term that needs to exist so you can have something to compare a data warehouse to that you can sell to the VP of whatever. A data lake is basically deciding to not do anything and then like do some queries. It's the opposite. Like I'm going to do nothing. I'm going to say that what I already have is a data lake. And like I said, if what I have is one query that I have to run every month, I am going to tell the CEO that we're using a data lake, and they are going to say, cool. And again, people will be happy to give you tools like this, but then I would propose we already have tools for this. I could write this Spark, right? Spark can read a Java database connector table, and it will push queries back, or it will push filters back, right? So if I take this data frame and I say only customer equals X, then that will become part of the SQL query that eventually runs when I materialize this. Or I can do it manually if I want. Or I have some CSVs over there, and I have a text file over there, and then I'm going to do some analytic work on it. Well, this isn't weird. This is normal Spark code, maybe with a very diverse set of inputs. That's fine. I know it's legal. And if I have one query to do, or a small number, and they run nightly, and I can just run them overnight where the load on the database doesn't matter, this seems totally cool. I just invented a data lake without doing anything. Great, right? So there's obviously a trade-off here. If I don't have much, if the place my data lives is reasonable, like if I'm just querying some totally normal, reasonable Postgres database that has a nicely normalized thing, I'm probably happy with that. If I'm querying the stupid PeopleSoft database that is insane and obviously these people were on drugs, maybe it's worth doing an ETL step first. Weirdly, I think you can end up where it makes sense to not have a data warehouse on either side. If I have kilobytes of data, who cares? Why are we talking about any of this? Why would I set up a data warehouse? It's not worth it. Or if I have petabytes of data, I am not going to make a copy of it. Whatever I can do with it in situ, that's what I get to do, and everything else isn't going to happen. So I don't know, like I think the term data warehouse makes sense to me in that it gives me a word to associate with this concept of wait. It makes sense to make a copy of my data, maybe a gently modified copy of my data in a different place where OLAP is efficient because I have a lot of analytics to do. If I have a data science team, probably that data science team should have a data warehouse. On the other hand, I think this happens a lot. I think definitely a lot of people, maybe the people who are less technical, have gone to some trade show and been told, you need a data warehouse because you need insight into the data. Well, half of that is true, right? You need insight into the data. You don't necessarily need a data warehouse for that. Maybe you need a data lake. And again, that is a sales pitch and it's a term that sounds like it's competitive with data warehouse. What data lake means is we can just leave it where it is. It's fine. Just chill. Depends what you got. So again, I think you need the term data warehouse in your life. I think ClickHouse is another tool to keep your eye on. Like along with these data frames tools, I think ClickHouse is super cool. You can just Docker run it or whatever. Like you can just it will exist in a Docker container if you want it to. It's pretty easy to bring up. And then maybe it's cool. Maybe you like SQL. And if you like expressing yourself as in SQL, ClickHouse and DuckDB are great. If you like expressing yourself in Python code with data frame-ish kind of operations, I think Polars is just worth keeping an eye on, along with the ones you already know. I think what I'm going to do is stop. This will be certainly less than 2 hours next week, but that's fine. Again, you don't have to commute for it. So I'm going to stop there. And I'm going to tell you to have a good week and have these last couple exercises where we knock out some more Spark stuff are cool. Get started on the project. If you're not started on the project, this is a problem. We are now at a point where this is not, hey, I think you should. This is no, seriously. Anyway, see you on Friday and in next week's lecture.